scared to get the premise wrong?
You scared.
Agree, disagree?
You scared.
Is it really wrong?
You scared.
True or false?
You scared.
This is our project. Woo!
The diagonals of a rectangle are equal in length. Is that true or false?
False.
Well, I'm going to prove you wrong because
Do it.
it is true.
Okay.
So, we have a given rectangle, and we have these two sides are equal in length, and these two sides are equal in length, which makes them congruent. If I draw the diagonals, they will both be equal in length because these two sides are congruent, and these two sides are congruent, making the diagonals congruent and equal in length.
I gotta admit, this time you proved me wrong. The diagonals of a rhombus are perpendicular bisectors of each other. Agree or disagree?
I disagree.
Let me prove you wrong. This is a rhombus that's given, and I will draw the diagonals. And I will prove to you that they're perpendicular. Because this is a 90 degree, 90 degree, 90 degree. What makes that this statement true?
Oh, okay. I agree now.
The diagonals of a parallelogram bisect each other. Do you agree or disagree?
I disagree.
Why? Do you not believe that they bisect each other?
Yep.
Well, let me prove you wrong. Okay, so I'm gonna draw a parallelogram, and I'm gonna draw the diagonals. Right here in the middle, this is where they're bisect. Do you agree or disagree now?
Oh, I agree now.
Okay, good.
The diagonals of a parallelogram bisect the opposite angles. Is this always true, never true, or sometimes true?
Sometimes true.
Are you sure?
Positive.
Let me prove you wrong.
Okay, show me.
Here we have of our parallelogram. These are called opposite angles, and when they are bisect by each other, that shows that they are cut in half here because they're opposites. This is opposite of this, and it clearly shows here they are cut by each other, which makes them bisecting angles of the parallelogram. The consecutive angles of a parallelogram are supplementary. Is this always true, never true, or sometimes true?
Never.
It's never true.
Never.
Can you please
I'm
explain?
right. Never. Never.
Let me show you why you're
Never.
wrong.
Fine.
Pay close attention. Here we have a parallelogram here to show. This is a question already given that this is 60 degrees here and this is 120 here. In order for it to equal 180, this has to be 120
You're
degrees.
wrong. It's never.
And this one for 120, the reflected is always 60 degrees. Add that up for me, Jordan. What is 120 degrees plus 60?
200.
Jordan.
I'm just kidding. It's 180.
So that proves that when we have consecutive angles, this angle and this angle, or this angle and that angle,
You're wrong.
will
You're wrong.
always and be true to equal 180 degrees.
Okay, so let's look at question number 6. The diagonals of a trapezoid are congruent. Is it true, sometimes true, or never true?
Never true.
Are you sure?
I'm positive.
Okay, well, you're wrong. Do you have any other guesses?
Nope. Always never true.
Okay, let me show you why you're wrong.
Prove me wrong.
Okay, so you have your trapezoid here. Thank you. And this is going to be A, B, C, D. And the only way that we can prove that AD and BC, or the diagonals, are congruent is if all of the corresponding parts of the trapezoid are congruent. So let's prove it. Well, since we know that this is isosceles, we know that AD is going to be congruent to BC. And also the base angles of ADC is congruent to BCD. So now we know that AC is congruent to BD because the base angles are congruent, and we have two sides of the trapezoid that are also congruent.
Oh, now I get it. Thanks for proving me wrong.
Okay, so let's look at question number 7. The diagonals of a kite bisect each other. Is it sometimes true, never true, or always true?
I think sometimes, because you know when you look at a kite, like not always do the diagonals, they don't always bisect each other for a kite, so I'll say sometimes.
Well, the answer is always. Let me explain. So can you hold that?
Yes.
So you can look at a kite in many ways, but let's look at it as two isosceles triangles. Or four right triangles, as you see here.
Oh.
So the non-vertex angles are here, right? But as you can see, these are the diagonals, because the diagonals root from one vertex. Right? We have one here and we have one there.
And
This
that's how it
always-
shows it.
Yeah, it always creates a perpendicular bisector. And so therefore, the diagonals of a kite always bisect each other.
Oh wow, I didn't even think of it that way.
Hurrah!
Here we have a parallelogram bisect angles of the opposite sides. Here we go with the bisect angles. They're always bisecting each other. Always true, sometimes true, or never true. Always true, always true.